guys, welcome back to Symbolic Logic Part 19. So far in Symbolic Logic, we have seen about specific forms in the previous video. In specific forms, we have learned about contradictory statements, contingent statements, and tautology statements. As we can recap, tautologies means the argument or sentence will be true, and when it comes to contradictory it will be always false, and when it comes to contingent, according to the situation it may be true or may be false. So using as we understood the meaning of these three terms, we will be solving some problems using this three terms. So take a look at the example one. What they ask is use truth table to characterize the following statement form as tautologous, self-contradictory, or contingent. So what we have is we got a argument, right? Or a statement we can say P material implication, P material implication, Q conjunction, negation Q. So as from truth table which you can see in the screen at the right side top, we will be having a unique consistent values for P and Q as TT, TF, FT and FF. If you refer my previous videos, you can see many examples which we have solved using this truth table, and this terms like conjunction, disjunction, negation, material implication, and biconditionals. So, what will happen is negation Q will be F. So, if we take negation means we'll be taking the opposite of Q. So, F T, F T we will getting. So, what next we are doing Q conjunction negation Q. If you if you do q dot negation q, which is in the that is t dot f, f dot t, t dot f, and f dot t, you will be getting false for everything. And the next theme which you are performing is p material implication, uh, q conjunction negation of q, with by solving it you are getting ff and tt. At the final, after getting all these separate terms, we are solving the main statement or argument. In that we are getting ttff. You can check my previous video to study how to solve these truth tables, using truth tables, how to solve these statements or arguments. So in the last column, some truth values are false and some are true. Right. Therefore, we conclude this statement is in the form of contingent. Contingent means it will be a mix of true and false. It may be true or may be false based on the situation. If we see the example to use to table to decide if the following is biconditional, following biconditional is the tautology or not. What we say by biconditional is material equivalence. We say it as biconditional because the both the statements will have the same truth values. So we have the statement P material implication Q, biconditional negation Q, material implication negation P. So if we solve this statement, what we are getting is T of TT. Again, in the last column, we are getting some truth values as false and some as true. Therefore, we conclude the statement is in the form of contingent. As you can see, P material influence Q, we are getting T of TF, and on the opposite side, we have negation Q, material implication negation P. We also getting the same values T of TT. So, which implies this both the terms is in the form of biconditional. So in part 21, this truth table method is little bit inconvenient. So in part 21 of symbolic logic, I will be introducing a few replacement rules and many more toolboxes. Inside the toolboxes, we will be having many more formulas which we can use in the upcoming problems to solve in a easier manner than this truth table thing, which is very time consuming.